Okay, we're going to look at a problem uh, with subgroups, and we want to find a good sample size within the subgroups. So let's just look at this problem. Okay, a middle school has 150 students in grade 6, 180 students in grade 7, 125 students in grade 8. Okay, you want to know which subject is the favorite among the students in the school. Since you can't ask all the students, you will survey a group of them. Okay, which sample can best help you draw conclusions about the preferences of all the students in the school? Okay, so what we want to do, we have these different choices for how to do the sample sizes. We want the students, actual students in each group, okay, grade 6, 7, and 8. We want the proportion of the actual students to be proportional to the number of students in the sample, okay, comparing the 6th grade and the 7th grade and the 8th grade. Okay, so I'll show you. Let's just focus on choice A. Okay, I want to see if this is going to be a proportional sample. Okay, so I'm going to take 150 actual students in 6th grade over the 36 graders in my sample. I'm going to write that as a ratio, as a fraction. I want to see if that's equal to, actually approximately equal to, the 187th graders in school over the 27th graders in my sample, and see if that's approximately proportional to the 125 students in the actual 8th grade class over the 42 8th graders in the sample. You see, we want these three sets of samples to be proportional to the number of actual students. So we're just going to see if these are pretty close to being equal to each other. There's a harder way to do this. I'm not going to do it this way, but you could make this work. You could check cross products. You could see if 180 times 30 is equal to 150 times 20. And then you could do another problem. You could see if 125 times 20 is equal to 180 times 42. Okay, let's not do it that way. It works. But I'm going to assume you would have a calculator on a problem like this. If you have a calculator, the easier way to do it would be to change these two decimals. Okay, to change these fractions to decimals, just take the numerator, the top, divided by the denominator, the bottom. Okay, so if you take 150 divided by 30 in your calculator, you get 5. If you take 180 divided by 20, you get about 9.5. And if you take 125 divided by 42, you get about 3. Okay, those are not approximately equal to each other, so this would not be a good way to do the sample sizes. Because 5 and 9.5 and 3 are not even close to each other. You want these to be close to each other. Okay, let's look at B. I'm going to erase the whole thing here. We're going to look at choice B. Okay, we're going to take 150 actual students in grade 6, write that over the 19 6th graders in the sample. We're going to compare that to 180 7th graders in the group. Put that over the 23 7th graders in the sample. Okay, the 125 students in grade 8 over the 16 8th graders in the sample. And we want to know if these are proportional to each other. Okay, let's just use a calculator. We're going to take 150 divided by 19. You get about 7.9. It's a really messy decimal, but it's approximately 7.9. 180 divided by 23 is about 7.8. 125 divided by 16 is about 7.8. Okay, see how this would be a good this would be good sample sizes to use for this study. Okay, because the actual people in the groups is proportional to the actual people in the sample of each of those groups. Okay, try the next one on your own and then check your answer to that.